The way the clock algorithm works is we imagine that the frames of the buffer pool are laid out in a circle, like a clock, okay? And we're going to have a little clock hand, and that clock hand you can think of as pointing to the next page to consider for replacement. So right now it's pointing to this frame at the top, which has page 1 in it. So that's the frame we would think about replacing next. And the clock is going to go around, as you can imagine, frame by frame as the policy runs. In addition, you'll notice one extra piece of metadata here, which are these little rectangles in the corners of the frames. We're going to call these reference bits, and they're going to mark recently referenced pages. And you'll see this is going to give pages sort of a second chance to get referenced before they get replaced. You'll see how this works. So that clock metaphor is actually represented in a very simple way by having a clock hand is in our metadata, which tells us what is the frame we're currently pointing to, in this case frame 1. And for each frame, a reference bit that's going to say yes or no, is this frame's reference bit on or is it off? Okay, so let's illustrate the clock policy. Here we have a request to read page 7, and we have the clock hand pointing to the frame that it's pointing to. But that current frame has a pin count that's greater than 0. So we can't replace that frame. We're not going to do anything with that frame. We're simply going to skip it. We're going to move the clock hand along. And now we're going to say, can we use this frame to hold page 7? So the frame's not pinned. That's good. But it does have its reference bit set. And so all we're going to do here is we're going to clear that reference bit. We're going to set it to 0. And we're going to skip this frame as well. Now we get to this frame at the bottom. It's not pinned, and its reference bit is unset. So we will choose this frame as the frame to replace. We'll bring page 7 in here and let page 4 go away. And we're going to set the frame pinned like we always do in the buffer manager, because the caller is now going to work on this page. And we're going to set the reference bit to 1 as well, so that the next time the clock hand comes around, if this page is unpinned, page 7 will get a second chance to live before it gets replaced. And then we advance the clock. When we're done with all that, we finally return the pointer to the frame in memory to the caller, and they can work with the page. Now, if you want to get this laid out for you a little more carefully, we have pseudocode here in a sort of C++ style syntax for you to read. So you can see the current state of the clock hand is passed in, and a page number to be requested is passed in. And in the happy case here, we're just going to replace the current page with the page that's desired. So the happy case is when the pin count is 0 and the reference bit is 0. In that case, we can replace this frame. If the current contents of the frame are dirty, we're going to write that page back to the disk. We're going to read the new page into that frame. That's going to be our return value. It's going to be the pointer to that frame. Mark it dirty is 0, so it's clean. Mark the pin count as 1, it's pinned. Mark the reference bit as 1, it's been referenced. And then our return value is all set to go to be returned to the caller. We'll skip the else. We'll advance the clock hand in line 21. And then in line 23, we would return the return value. And that would be the end of the happy case. Now, in the less happy case, we're looking at a frame that's reference bit is set. And in that case, we have current pin count is 0, but reference bit is 1. So we simply set the reference bit to 0. The contents of that frame will not be replaced now. They'll be replaced the next time the clock hand goes around if they're not referenced before then. That's why we talk about it as a second chance. It has one time around the clock to get referenced before we'll replace it. And in the final case, we look at a page where the pin count is greater than 1, and we simply skip it and go back around the while loop looking for a frame to replace.